welcome to the present session of Mathematics for class 5th titled Area and Boundary. Well, regarding the title, the boundary must not be confused with anything else except the perimeter. Boundary has been very cleverly chosen for perimeter because to develop the clear concept in students that perimeter is nothing but the boundary. Now, this perimeter is comprising of two words. One is peri and second is meter. Peri is around, peri means around, and meter is to measure. So basic concept of perimeter is to measure around. So, and in other terminology we say measuring the length of the boundary is perimeter. We will be talking about this perimeter more elaborately later in the session. So, what we are going to have in this present session is we have to deal what the area is, second what the perimeter is, and I think you must be clear now that boundary and perimeter are exchangeable. They mean one and the same thing. Third thing, though there are so many possible figures in mathematics of which we can calculate the area and perimeter, but we will be focusing on some basic figures that are available in mathematics. That is what the textbook is focusing on. Primarily square and rectangle are the prime focus of the textbook for class 5th of NCERT. So, we will be dealing much more elaborately with square and rectangle. And in addition, there is basic figure that is triangle. We will be talking about it in a while. And after that, describing what the triangle is, what the square is, what the rectangle is, we will be looking for the method to measure the area and perimeter of triangle, square, rectangle, and etc. Primarily these three, and lastly in the session we will be looking at, okay, we have done everything. We have seen what the square is, what the rectangle is, what the triangle is, and many more things related to them, but why to measure in the and at the end of the session we will be looking why we will measure, what is the need to measure these things. And lastly today we will be having one more basic figure, that is circle if time permits. Right. So, starting with the first concept, that is area. So, what the area is? Area is measuring the surface of any closed region. I will write it first. Of simple closed region. Now, regarding the definition, it says that we have to measure. Okay, firstly we know that we are going to deal with the measurement, whether it is around the boundary or the area itself. But for the present definition, that is measure the surface of simple closed region. Now, there is one abstract word in it, that is closed. That is area deals with the closed figures, right. Now, what this closed figure is? Now, we have to differentiate it in terms of its antonym, in terms of its opposite thing, that is closed, and second one is open. By closed we mean it is bounded on its all surfaces. Let us have some examples to understand what the closed is. Suppose I have some figure like this. We can see that it is bounded on its all its surface surroundings. So, it is a closed figure. We will not name them anything yet, just we are drawing the simple closed figures. This again a closed figure. This one is closed figure again. This one is closed figure again, and the list can go on and on. So I hope you understood what the closed figure mean. It is bounded on its all surroundings. It must not be open from anywhere. So now drawing the open surfaces, it will make it better. Suppose I have some figure like this. It is open. It is not closed, from all sides. Similarly, let me draw this figure. It is a ring, but it is not bounded. It is C-shaped. It is not circle. So it is open from this side. That is why this is open from this side. That is why this is not a closed figure. It is open from this side. That's why it is not a closed figure. So the first and foremost thing is that we are in area we are dealing with the closed regions, right? And we are not dealing with the open figures. Open figure means that they are not bounded on its all surroundings. I hope this is clear now. Next we will see area of some basic figures. We will be starting with the triangle. We will see the triangle, its area and its perimeter. So I hope we have already discussed about perimeter, that is measuring the length of the boundary, okay, and area is measuring the closed region. So if I draw a simple triangle here, firstly let us calculate its perimeter, okay. Let this be 5, this be 5, this be 4. That is, it is 3 boundaries, 3 sides are 5, 5 and 4. So calculating the perimeter of the present triangle is like measuring the length of its boundaries, that is 5 plus 5 plus 4, which is equal to 14. So the basic concept of perimeter holds true for all types of the triangles. We know that there are 3 types of triangles mainly, that is equilateral triangles in which every side will be equal, and second is isosceles triangle in which 2 sides will be equal, third will be different, and third one is scalene, that is every side measures differently. So if we so this kind of triangle is isosceles triangle because we have 2 similar sides, that is 5 and 5. Now if we replace this 4 with 5, it becomes isosceles triangle, and again we know that isosceles triangle, the concept of perimeter lies the same, that is we have to add up the boundaries, that is 5 plus 5 plus 5, okay. And for the scalene triangle, every side will be different. So this will be say 4 and this will be say 6. So we can see that every side is different, that is one measures 5, other measures 4 and other measures 6. So this is scalene triangle, and in which again the concept of perimeter lies the same, that is 5 plus 4 plus 6, that is 15, okay. So this was about the triangle. Now we will be having brief discussion about this square and rectangle. Regarding this square, suppose we have in a classroom, in one of the classrooms, suppose we have 3 lines, okay, and each line contains equal number of students. That is, we have 3 lines 1, 2, 3, and each line contains equal number of students, that is 1, 2, 3. In this case, when we have equal number of lines and every line contains equal number of students or objects, we call this as a square. So basic concept of square is that we have equal number of rows and equal number of columns, or we have equal number of objects in one row and equal number of objects in one column. This object can be students or anything else. Now if this is a square in which every line contains equal number of students and we have the equal number of lines, this is square. Now how it can become a rectangle when we have unequal number of rows and columns. Suppose we have, so this is square. I hope this is clear. This is a square. Now if I add one more row to the already existing figure, it will become a rectangle. Suppose this is 4th row. Now this does not remain anymore a square, it becomes a rectangle, because here we number it from 1 to 3 and from here we number it as 1 2 3 4. So I hope you understood that when we have 3 number of rows and equal number of columns, that is we have 4 rows 4 columns, it is square. We have 5 rows 5 columns, it is square. We have 6 rows 6 columns, it is square. And when we have the different number of rows and columns, we call it as rectangle. Suppose we have 4 number of rows 5 number of columns, then it becomes a rectangle. Now we have to deal with the perimeter of this square and rectangle. As far as the square is concerned, let us draw some square. It is, suppose it is 4, it will be 4 from here, it will be 4 from here, it will be 4 from here. Okay. So calculating its perimeter will be like adding all the boundaries, that is 4 plus 4 plus 4, which is equal to 16. We are talking about the perimeter of the square right now. Okay. Or in other senses, we can say that let this side be S, let this side be, if one side is S and every side is equal, so every side will be S again. It is S again, it is S again, it is S again. So adding all the sides means adding all the sides. Let us have it like it is S plus S plus S and plus S, that is 4 times S. So calculating the perimeter of a square is adding all the sides. If one of the side is S, so it becomes 4 times S, right? And second is rectangle. I hope we already know now what the rectangle is. We will be having concept of perimeter applied to the rectangle. Let this be L, this be B. So this will be L again and this will be B again. Okay. And in calculating its perimeter, that is perimeter of a rectangle, we'll be adding all the surfaces, that is we'll be adding this L, we'll be adding this B, this L and this B again, and it will sum up to, this is L plus L is 2L, and from here it is 2B. If we put 2 as a common, so it will become 2 into L plus B. So this is the formula for calculating the perimeter of the rectangle. Without calculating, without using the formula, we can even calculate, but that method is of course slower. Suppose this is 5 and this is 3. So what we'll be doing, without using the formula, we'll be adding, this is 5, this will be 5 again, so 5 plus 5 is 10, this is 3, so it is 13, and plus 3 is 16. Okay. With this will be like 5 plus 5 plus 3 plus 3. So, it will become 16, or we can use directly the formula, that is 2 into L is 5, this is 3. So, 5 plus 3 is 8, 8 into 2 is 16. So, until this point we have understood two formulas. We have learned two formulas. One is for square and another is for rectangle, and both are related to the parameters. Okay. So, one of the formula is 2 into L plus B, and second is 4 into side. Now, we will be having second method, that is area, and for area we have two methods. One is called counting the number of squares. Okay. Let us again demonstrate of a square. This is a square. We know that this is square because it contains equal number of rows and columns. Now, the first method says we have to count the number of unit squares. Second method says use the formula. We will be using both the concepts in both rectangle as well as square. First we will be using it for a square. So, this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. This method, that is counting the number of squares, it sums up to 9, that is the area of this square is 9. By which method we use it? We use it by the method of counting the number of squares, dividing the surface into unit squares and counting the number of squares afterwards. And similar way we can use this counting the number of squares for rectangle too. Then we will afterwards we will be using as a formula. Let this be rectangle having the 4 rows and 3 columns. Now, this does not remain square because we have the unequal number of rows and columns. I hope you understood it. So, in a rectangle it contains 3 rows and each row contains 3 objects. So, we are calculating the area of rectangle by counting the number of squares. So, if we have this sort of rectangle, its area will be 12 because the last square sums up to 12. So, this is one of the method, counting the number of squares in both square as well as rectangle. We saw it, though this is very simple, but not used in a practical ways. In practical methods we use formulas. So, what are the formulas for calculating the area of square and rectangle? For square, if we look at square, actually it is a line. It is one line, let it be of size 5, and suppose we add this line 5 more times. If we are adding okay. So, this is one line measuring 5 and we have added it 5 more times. Okay. So, this is do not confuse these lines, consider them as one, these lines. So, these are 5 lines, one line measure 5 and we have added it 5 times. So, this 1, 2, 3 and 4 and 5. So, of course, this is now a square. So, we have added a line measuring 5 times. So, this is nothing but 5 into 5, simple multiplication. We have a line measuring 5 and we have added it 5 times. So, this is 5 into 5, or if this side is a and we have added it a times, so it is a into a. So, this will basically be nothing but the a square. Similarly, we use this concept for rectangle too. In rectangle we have a line L and we have added it b number of times. So overall area becomes L into B. We have line L and we have added it b number of times. So this is nothing but the L into B. Okay. So we have concluded square and rectangle. So the formula for square is a into a, or if the side is a, then it is a into a, that is a square. Otherwise, if the side is s, then s square. And for rectangle, we have L into B. L is the length and B is the breadth. We have line L, we have added b number of times, then it becomes L into B. Of course, if we have the line L and if we add it L number of times, then it becomes a square. Okay. So basically, we have 4 formulas now. One is a square, second is L into B, third is of the perimeter of square, that is 4 times, if the side is a, that is 4 times a, and fourth one is of the rectangle, that is 2 into L plus B. Next concept in it is, okay, we have the methods, we have 2 methods of using formulas and counting the number of squares, but why we need to measure? Why what is the need that we need to measure the perimeter and the area? Suppose, one of the example is, suppose this is a room, rather the floor of the room, this floor, and I have to carpet flooring of this room. Before buying the carpet for this floor, I need to measure it. How do we measure it? Either the room will be of rectangle or it will be square. So in either case, we need to measure it before actually getting the carpet for the room. So one of the example is carpet flooring. Second example, suppose I have to laminate the door. I have a door and I have to laminate it. Of course, you can see this door is rectangle. Okay. Now, of this door, if I need to laminate it, I need to find its area first. If I can find its area, then I can laminate it according to its area. So second example you understood about it is laminating the door. Of course, both the examples are related with the area. Okay. Now let us have one of the example regarding the perimeter. Let this be the field and we need to fence it. We need to fence it on all sides. That is, I have to fence it from this side, I have to fence it from this side, I have to fence it from this side, and I have to fence it from this side too. So what we are doing actually, this fencing this field is nothing but calculating its perimeter. So basic concept of having this measurement, that is perimeter or area, is actually to calculate the area and the perimeter, which are very much useful and very much used in day-to-day lives. Okay. So lastly, we have in this session we have circle. Circle is now this circle, its area is pi r square and its circumference is 2 pi r. We will be actually looking at why this is pi r square and why this 2 pi r. Okay. But let that be in other session. Okay. So what we have learned so far, we will be revising it in a while. So we started with the topic, that is area and boundary, and we talked that boundary is nothing but the perimeter. Secondly, we saw that area is measuring the closed surface, and in day-to-day life we saw that closed surfaces are like the room, classroom. Classroom is a closed surface. Room in our homes is a closed surface, or box of sweets is a closed surface. Okay, any fenced park is a closed surface. We saw that there are two types of surfaces, that is closed surface and open surfaces, and in area and perimeter we deal with the closed surface, not with the open surfaces. Then we saw basic concept of what the square is, what the rectangle is, what the triangle is, and we talked about their perimeters and areas, and we saw that there are two methods of calculating the area and area of the square and rectangle. One was the counting the number of square, that is very much a layman method or the primitive method, and second method we saw by using the formulas. And lastly we saw why do we need to measure. Actually whatever we learn in mathematics, that is applicable in our day-to-day lives, and that is why we are having this topic, that is area and perimeter. And we saw that how concept of this area and perimeter was used to calculate the carpet flooring of room or fencing of a field and others. And lastly we talked about circle in a brief, that is perimeter of a circle is 2 pi r and area of a circle is pi r square.